This video is going to show you how to solve one of the review problems, number 41 on the worksheet. A roller coaster car travels off a hill while traveling downward. How long is the roller coaster car in the air? How far from the edge of the broken track will the roller coaster car land? And with what speed and direction will the roller coaster car impact the ground? I'm going to slide this diagram over a little bit, make some room. So here's the initial velocity going downwards. It's 25 meters per second, and the angle swings over with the vertical, 33 degrees. So it's going down, that's the angle right there. Now what I need to do is take my angled velocity and turn it into horizontal and vertical velocity so I can put it in my table. In my table of givens, you can see how it's made up with two columns. We have our little rule that says every time we have an acceleration, we have a column of givens. So I've got my kinematics variables, VO, X, TVA, or as we call them, Vox, TVA. And I created a vertical column with one acceleration of negative 9.8 meters per second squared, and the second horizontal column with a new acceleration of 0. So this becomes my table of givens for projectile motion. Alright, back to my triangle. 25 meters per second, 33 degrees. I need the vertical component of the velocity. That's going to be 25 meters per second cosine 33. So to organize my work, I'll put that in the vertical column for the initial velocity. And it's negative because it's going down. Complete my triangle, initial velocity triangle with a horizontal line. And that becomes the Vx naught is 25 meters per second sine 35. And again, to organize my work, I'll put it in my table. So now it looks like I'm almost done, but I've got one more piece of information that I can see on here, and that's going to be how far it fell as well as the final horizontal velocity. So the final horizontal velocity is 25 meters per second sine 30, same as the initial because there's no change in velocity due to the zero acceleration. Last piece of given information is how far it fell. So where I started at the top, I'm going to make that 0, which means it fell down. Its final displacement is negative 125 meters. So again, I'll put that in my table for the vertical givens. And it goes in the vertical, not the horizontal, because I'm falling down in a vertical direction, not left and right in a horizontal direction. That's why it's in the vertical givens. Now, let's look at the questions. How long is the roller coaster in the air? So I'm going to find the time with just the vertical givens. And I'm finding it with the vertical givens because I have enough information, enough variables. I have 3 variables and I can find the 4th. Horizontally, I don't have enough variables to solve this. So I'll find the time with the vertical givens. That's going to say x is equal to x naught plus v naught t plus 1f at squared. And I chose that equation because that matches the variables with the time in it. Put in my numbers, I get negative 125 is equal to negative 25 meters per second cosine 33 times t plus 1/2 negative 9.8 meters per second squared times t squared. So I get my two values for time, one positive, one negative. Positive is the only possibility because we don't have negative time. So 3.35 seconds is the right answer. To organize my work, I'll go ahead and stick that in the table. Now let's look for the next question. Find the range of the horizontal givens for the next question. So I'm going to use just the horizontal column this time. The range is equal to Vx naught times t. That's our only equation for horizontal motion. That's all we have because acceleration is equal to 0. So I'll put in my horizontal values, 25 meters per second sine 33, and then the time. And that'll give me the range, 46.56 meters. So that's far it's traveled horizontally. Last question. I need to find the vertical impact information when it hits at vertical velocity. So I'm going to do that, I'm going to find the final vertical velocity first. So the final vertical velocity, to find it, that's the empty spot on the vertical column. I'm going to use the VOAT equation. I could use the v squared equals v naught squared plus 2ax equation equally well. So if I use VOAT, I get v is equal to negative 25 meters per second cosine 33 plus negative 9.8 meters per second times the time. And I get my final answer of negative 53.75 meters per second. Now using the other equation, v squared equals v naught squared plus 2ax, might have been a better choice because I calculated the time, and if I calculate the time wrong, I'll just propagate that error. But if I use the v squared equals v naught squared plus 2ax, well, there's nothing calculated in that using that formula, so that might have been a better choice. There are two triangles in projectile motion. One is when it's launched, and that uses the very top row of givens. And the second one's when it's landing, and that's that v, the final velocity, which is the second from the bottom row. So when it lands, it's going to hit some angle, some speed. And to find this angle and speed, I need to create a triangle using these variables. So vertically, I know that it's going to be 53.8 meters per second going down because it's negative, so I'm going to get rid of the negative sign. Horizontally, it's going to be 25 sine 33. It's always the same as the initial velocity horizontal. It doesn't change. Now I use trig and geometry. So to find the impact speed with all those final velocities, I'll use Pythagorean's theorem, plug in the horizontal and vertical velocities, remember not distances, velocities, and I get 55.4 meters per second. To find the direction, that's going to be the angle, so I'll do tangent theta is equal to the opposite over adjacent, which is the 53.755 meters per second divided by 25 sine 35. When you're doing this, be careful with the calculator. You need to make sure you put second pair of parentheses in the denominator in order to get the right answer. You ought to try it just to see, make sure you try it, see if you get the right answer. And the theta should come out to be 75.8 degrees with the ground.